Welcome everybody to the WasmEdge community meeting. This is the 5th community meeting. These are a monthly meeting on the first Tuesday of each month at 7 a.m. PST, or that's equivalent to 11 p.m. Hong Kong time. Welcome everybody. We have a good lineup tonight. We're going to do a kickoff with a recap of WasmEdge in 2021, and I'll be doing that presentation shortly. And we're going to hear from Michael about the outlook of WasmEdge for 2022. And we'll also have some Q&A. And I see a lot of participants here joining us, which is really great. Thank you so much. I would actually like to, if we don't have any specific Q&A, if people would like to actually just introduce themselves and let us know quickly what they're working on. We'd love to help you guys out, and we love to share and collaborate online, and everything is open source and available, including the documentation. So any questions are welcome, but we also might just have a quick run through some of the participants and just share things that we're working on. We've already seen some fantastic uses of WasmEdge in the community and in business and enterprise and so forth. So that'd be really great to connect there and share our stories. All right, so looking good. Everybody's logged in. I will begin by sharing my screen and kick off on this recap of WasmEdge in 2021. So WasmEdge, formerly SSVM, so that stands for Second State Virtual Machine. And back then, around January, we were doing a lot of work with the Second State Virtual Machine. A lot of the features that we implemented were aimed at getting it used. We had a node, essentially a plugin, and we could allow people to use the virtual machine over the web just using HTTP requests. There was always this notion of gas metering, so computational effort was measured and recorded, and some of the features, we could turn on and off again, things like that. The development of all those things has continued. Actually, from memory, pretty much, everything that we've been working on or working towards integrating support for different things like TensorFlow and those WASI-like features that we supported. On one hand, we're waiting for the WASI implementation. Very happy to follow on with any WebAssembly paths that are taken by the community or by the WebAssembly working groups and so forth. And then on the other hand, we were also implementing in parallel support for a bunch of other features and things like that, just so that we could try and implement as much functionality in the VM as possible, with the option to completely conform to any official standards and things like that. So we've remained very flexible and tried to make it as feature rich as possible, and I think that's been the case. It's been a really amazing year of development. Following on from that, in the early part of the year, obviously the CNCF has accepted WasmEdge as a sandbox project, and that's been really great. So we've managed to open this up to a wider community, get more awareness, a lot more users and things like that, which is really great. And then around May, we had the WasmEdge 0.8.0 release, and then moved on there to the 0.8.1 release. Around August, we went to 8.2, and then as we saw just recently, we went to the 0.9.0, which was really great. And Heide gave a really great release notes, a description of all the features and things like that. And if you watch the previous videos, the previous video has a brief summary of the 0.9.0 release. If you go back to the third, I think it is, WasmEdge community meeting, you'll see quite an in-depth, Heide walks us through all of the different components and features and things like that, and some breaking changes. So it may be worth, if you're an early user, if you wanted to have a look at that video, that would be really informative. So the features update in 2021, a summary there is we've essentially made it cross-platform. So we're adding Mac OS support, Windows support, the SEL4, the real-time operating system support, and also the ARM32 support. We've got some videos on the SEL4 implementation. If you want to check those out, that was really great. And I'll just check the chat. Seeing the chat there. Okay, cool. Over there. And the WASI-like extensions, I mentioned just briefly before that we've created some functionality where we've implemented additional features. One of them is the networking socket, so the ability for us to actually, instead of being completely isolated in the virtual machine environment, is actually allow us to communicate outside that on purpose. You know, this is obviously deliberate, and it's something that you enable deliberately. And so the network socket was a big one. We were able to actually break out of the VM briefly and do some network interaction there. The other features that we've had in the WASI-like extensions was where we implemented things on the host, where you could do things like OCR, like optical character recognition. We did a language translation using Tesseract, so we're able to put in a language and choose a variety of languages and do translation. One of the examples was we could read an image, extract the text from that, translate that to another language. And then, of course, the other work was the TensorFlow work, where we're doing object recognition, facial recognition, and object detection, things like that. So we have videos on all of these. And if you want any information, or if you have any questions, please give us a shout, because it's actually really interesting. So the JavaScript support, the ES6 module, and standard API support. We implemented the JavaScript APIs in Rust. Again, we might even just give you a brief look at the book. I'll pull up a link and we'll show you that. Michael actually ran through that 1 or 2 videos ago. That we have excellent documentation. We have a WasmEdge in online book format, which walks you through all the demos and things like that. So definitely worthwhile checking that out. It's a great read, and you can follow along. It's well written. We import the C native shared library as well, and functions as JavaScript functions. So language bindings, Go SDK, Rust SDK, the Java SDK is ongoing, and so is the Python SDK. So if you have any queries about those, also please give us a shout. We can support you there and help you out. So in the cloud native management and orchestration space, we have this OCI compliant, so the Open Container Initiative compliant WebAssembly runtime. And we're able to now integrate the WebAssembly runtime into being managed by Kubernetes tool sets and things like that. So we saw a really great example. I see Sven's joined us here. We have a great demo a couple of videos back of reply.de, the implementation of our WasmEdge in an OCI compliant space using Kind and things like that. So we have Kubernetes, OpenYurt, KubeEdge, Kind, Containerd, and crun, and these have actually been implemented solidly in those technologies. So definitely well worth checking out. The integration is superb, and you can get a lot done with this. So you know, relatively early days in this space, and I think that Sven was saying, you know, he's come across it via GitHub, tried it out, used it, implemented it, and it works great. I think that there could be and should be a lot more awareness of the integration of WasmEdge into this cloud native orchestration environment, and very, very useful, and definitely a good use of our tools. The community's grown, which is really great. GitHub's getting very popular. The WasmEdge is getting discovered just naturally online, and the contributors have increased, which is really good to see. A lot of activity, a lot of questions, a lot of people tagging in and helping and picking up GitHub issues and features, which is really great to see. So a nice solid community. And here's the docs, the book that we're talking about. So wasmedge.org/book/en. If you go check that out, it's really well written. You've got your menu system down the side. You just step through all the pages, follow on with the examples, and in no time you'll be up and running, and you have it all installed. We've just got single line commands to install the tool chains and things like that, and get you up and running very quickly. And obviously with the different SDKs, you have a lot of flexibility to use this and the containerization components, you have a lot of ability to use this in any project that you're working on very easily. So if you have any dramas getting up and running, please contact us via GitHub or pop along to these meetings, ask some questions. We're more than happy to help. And the developers on the team are all phenomenal. So you'll get awesome help quickly and get you up and running. Integrations, as I mentioned before, like the OpenYurt, the Kubernetes, we did Dapper. I did a video a while back where we actually had a Dapper integration with WasmEdge. That was really great. There's a couple of videos on that actually. And as I mentioned, like SEL4, we've actually integrated it with that and done a couple of videos, and there's some good awareness there with that team and the work we've done. And I believe that is about the end of this presentation. So I'm going to next hand over to Michael, and I'll just unshare my screen first.
All right.
Hey, Michael, welcome.
Hi.
Hello.
Thanks, Tim.
Hand you over.
Yeah.
Pleasure. I'll mute myself.
Okay, it turned off. Okay, so great. Yeah. Hello, everyone. Yeah. So I remember our last community meeting was on January 4th, and I was I attended that from a car, right? If you guys remember, I was in the parking lot outside my home in Austin, Texas, and immediately after that meeting, I drove to Dallas and took the American airline flight to Shanghai, and I went into quarantine in China because the quarantine everybody came from the United States, and I'm still in quarantine. This is my hotel room, so it's just amazing. It has been 4 months, and and this journey hasn't. I haven't even met anybody. That's during that entire. That's during this entire time because I'm only in quarantine, but I'm not complaining. But just let you know that things is a little bit of deja vu for me because I remember the last time precisely a month ago that we took this meeting, and I was in the car. But anyway, so before I start this little presentation, let me share with you a little photo. Okay, can you guys see that? Yeah. So why am I sharing that? Because today, actually right now, both in China and in the US, and it's a Chinese New Year. It's a year of tiger. So I appreciate our team in Asia coming online because it's New Year's Day for them. It's a holiday. It's a very big holiday. So so in this meeting, we're going to talk about the future roadmap of WasmEdge, and we welcome everyone to ask questions. If you ask a question, we're gonna send you one of those. That's I don't actually know how they are, but I imagine it's about this big. So it's a nice toy you can put on your desk. Or you can get a gift card. But I just want to say I appreciate everyone to be here, and so if you have a question that's you want to ask, you can interrupt me, or you can wait until the very end, and just email us your mailing address, and we're going to send you something. All right. So then let's go to where okay, stop sharing. Then I want to share another screen, which is the main thing I want to talk about. So here we go. So yesterday we published a roadmap of WasmEdge. That's to talk about what's going to happen in the next year also, essentially in 2022. So we listed the things that we want to do, and we want to our team want to do, and we want to see what's happening with the community. And we also looked in, went through all the GitHub issues that we have currently in our repository. So it turns out we have a lot to do, in this year, I think WebAssembly has really taken off, So, but before I get into this particular list, I want to talk to you a little bit about, just to add on what Tim has said, things that happened in the last year, right? One of the big things that we did was that we provided HTTP, a networking socket interface for Wasm. And if you look at other Wasm runtimes out there, and some of them are also using Wasm to do, web services and, HTTP services of that nature. And they typically need a wrapper, they need something that's provide host function to wrap around their Wasm runtime, essentially have a custom built Wasm runtime. But with WasmEdge, that you are able to just have a networking API and use do HTTP GET and then do HTTP request and also serve HTTP request from your WebAssembly applications written either in Rust or in JavaScript. So that's really opens the door, because without the wrapper, then this this runtime can then be managed by Kubernetes. You don't have to have a special binary that Kubernetes has to be aware of in order to manage your runtime, right? So so with WasmEdge, it can be directly managed. But one of the I think important features I want to highlight with this network socket capabilities is that it is actually asynchronous, so it's non-blocking. Meaning that, so say if I have two HTTP GET requests that needs to go out from my application, right? So I send out a request and then I wait for the response. And during that wait, I can send out a second request. And when the response come back, I process it asynchronously. So that allows a single-threaded application to do multiple concurrent requests. And for the server, it's the same. So I'm listening on the server pod, and when a request comes in, and if I will need to handle it, and after I handle it, I send the response back. While I wait for the other party to respond or do something else, I can handle another request, right? So that's essentially the age-old question. When people first heard about Node.js, people say, in JavaScript, a single-threaded environment, how is it possible for it to handle on the server to handle concurrent requests, right? That's how it does. It's asynchronous, non-blocking networking is the key here, and we now have it fully supported in both our Rust SDK and in WasmEdge, and we provide this capability in our Rust SDK and also in our JavaScript SDK. And then we went a step further. That's in the JavaScript SDK, once you have non-blocking asynchronous networking, you'll be able to do something like a streaming response. So for instance, one of the most common use cases for serverless functions or microservices is to do SSR, right? That's a server-side rendering. So if you have, say, Vue.js or Next.js, that's so you would have a serverless function on the edge that essentially takes over part of the rendering work. And but server-side rendering, if you wait for the server to complete the whole HTML page and then send it back, it's often slow. So streaming SSR is one of the very trendy thing to do. So in order to do streaming SSR, you sort of have to have a non-blocking and asynchronous networking capabilities, which we have now. And now we have, for example, in our JavaScript tutorial, if you go to the WasmEdge book, let me show you that. You go to the WasmEdge book and you go to develop WasmEdge application, and then you go to JavaScript, you'll be able to see networking sockets. And it talks about, all the example here are asynchronous networking. So it has, a JavaScript async method, and Rust is the same story. And with and you can do React SSR, like I just said. There's static rendering, which means it renders all the HTML and JavaScript in one go, in one function call. Or it can do the streaming rendering. That means it would return the shell of the page and then return elements of the page piece by piece as JavaScript. And now now we have the infrastructure to do all that. That's people ask, why don't you use Node.js to do that? And the reason, of course, it's with this approach, it is much smaller than Node.js, much more manageable, and also it can be managed directly with a container because WasmEdge itself is an OCI compliant container, right? Unlike Node.js and V8, which you have to run them inside the Docker. So, and then we also provided functions like fetch. If we work in the space, that should be, sounds familiar to you because that's one of the most commonly used JavaScript networking function inside of the browser. And because it's so commonly used, so companies like Cloudflare, they also build their infrastructures on top of that. So by supporting fetch, that we were able to support a lot of existing JavaScript libraries and components out there for server-side development. So those are the things I would add on to Tim's comments about the achievement we had in 2021. And then just recently, I think last week, we were able to run, I think that's going to come out in WasmEdge release 0.9.1, is that we were able to run the run it fully on the Android device, right? So as we just said, we have Mac M1, we have Linux x86, we have ARM 664 both on Linux, we have Windows, we have Cell 4, we have all those, we have OpenHarmony, and now we can run it on Android devices. And we can not only run the WasmEdge interpreter on Android device, we can also run extensions. So that means if you have Android device that needs to do, say AI inference or facial recognition, things of that nature, you will be able to use WasmEdge to do that. So in the past, you would have to install the whole, the Python packages and all that stuff. Now you don't need to do that. You can have a very lightweight and very compact frameworks that you can use a modern language like Rust or even JavaScript to drive it, right? So those are some of the things that I want to add on. But then let's go back to the, if I can find it, I think it's here. Yes. To the roadmap, right? So what do we want to do in the new year, right? So first of all, there's still a lot of WASI proposals that we're going to finish, and some of them are almost done, slated to finish in Q1. Like WASI Crypto, it's a comprehensive cryptographic library written in, that will be available to Wasm applications. That allows, because if you think about the value proposition of WebAssembly, it has always been performance, and but if you have to do those computationally intensive cryptographic operations inside the bytecode format, it really slows things down. So to have a WASI format to reach out to those cryptographic functions that in SSL and things like that, it's tremendously helpful. And it's one of the nice side effects that I'm going to have for our networking socket is it's going to fully support HTTPS, which we don't support at this moment, because because in order to support HTTPS, you really do need all those cryptographic libraries, and those should be done. I think the coding work is almost all done. One of our contributors it is actually one of our interns from CNCF, right? So CNCF has those open source internship programs, and this is one of the interns that we recruited, and I think the coding is all done, and we are now finishing up the instructions, documentations, and reviews, and things like that. And then similarly, there's WASI-N proposal. There's we are currently supporting TensorFlow. That's very nice framework. However, with WASI-N, we would be able to support ONX, and I think it's OpenY, right? That's the Intel framework. So and we're also looking to support Baidu's Paddle. So there's a bunch of backend I would say tensor frameworks or AI frameworks that we could support with under the umbrella of the WasmEdge proposal. And the WasmEdge signature proposal is also interesting. It's also almost done. It is one of the very hot issues today. It's software supply chain security, right? It's that how do I know that's my Wasm module or my software come from the developer who claim it is, right? Other than relying on things like centralized services like npm and GitHub. Now with the signature proposal that that the developer would be able to sign their Wasm package, and then the runtime would be able to check the signature, and then only run. So at the runtime level, we would be able to specify that for this particular application, we are expecting it coming from this developer. So if it doesn't, so if the Wasm file does not contain the valid signature, it will not run, right? So those are, I think, very important features. And then there's thread-related issues. So one of the the slight issues about WasmEdge is that it is not entirely thread safe. Although it's thread safe most of the time, that's because we have a Go SDK and we integrated with project like Suborbital, where in their test cases they can spun off several thousand threads and have essentially have several thousand WasmEdge runtimes running at the same time in the memory, right? So those tests all passed without problems. However, if you write deliberate test cases where in the WasmEdge VM you would have applications that deliberately try to manipulate memory space, in some cases that there's currently lack of built-in protection, that protects the each WasmEdge instance from manipulating from instances in other thread in the same process, right? So we are working hard to solve this problem because as we know, Wasm is by itself a single-threaded environment. So in order for it to be used safely as an embedded function, that we need to provide better thread safety. So that's the thing that we are trying to resolve in Q1. That's again, coding is almost done, but it needs a lot of testing and things like that. So that's well, then there's a bunch of other issues. The other thing I really want to highlight is WasmEdge badging, which I think I talked about last time. We are tired of waiting for interface types, although, I hope that the interface types would be supported. The standard would be finalized and supported by all compilers, soon, but it appears to be taking a long time. And we can't rely on Wasm badging because Wasm badging is very specific to the browser use case. It's very specifically tied to JavaScript and Rust. So that's so that leaves us with no option. That we chose to write our own badging framework. So we now have it working on Rust and Go. And we are also looking for contributors to make it work across different SDKs that we have, and also work across different host Wasm languages like TinyGo, Swift, Kotlin, and things like that. So so that should greatly simplify the work of embedding a Wasm runtime into a host function, right? So that's something we are trying actively looking for help. And that's essentially to this is part of the overall developer experience, right? Is it possible to use WasmEdge without WasmEdge badging? Of course, it is possible. But there are lots of manual work the developer would have to do. That's essentially the experience that if you use Wasm today, it's that experience. If you look at their documentation, there's lots of direct memory manipulation. In order to pass a complex object like a string or array into an object, you basically have in the host and also in the inside Wasm. On both sides, you need to be aware, what part of memory it comes from, right? So that is, we think, the developer experience can be improved a lot, so that's why we have, Wasm badging. And then, one of the other things which I thought is kind of low-hanging fruit, but we'd also like to ask for help from the community's database connectors, because one of the the application that's is the most common server-side web application is a database-driven web application, right? So it's it queries a database and returns some kind of result, right? That's essentially in the past 20 years, all web frameworks or server-side frameworks has a demo like that. So with socket support, that we are able to support database queries, because most database you can access it through socket, right? But that requires us to do to actually decipher the wire protocol of that database and then build a driver for it, right? That's so almost all those databases have a driver for different languages and all that, but we essentially need a driver for WasmEdge. There's another way, is to just use the database C-based driver, and all of them have a C-based driver, and wrap a host function around it. That's essentially what we did with Berkeley's Anna project. That's something we're going to also talk about on Twitter, in the next couple of days. Is that the Anna key value store is a key value store developed by a team at UC Berkeley. And what it does is that it's an edge-based database, so meaning that it's a distributed key value database, and it's eventually consistent. So it does not aim to be synchronized across all edges at all times, but it tolerates some kind of delay. So on all those edge nodes, it would eventually be synchronized in, say, in seconds or in even minutes, right? But at any given time, it doesn't guarantee that. And that makes it suitable for a very typical WebAssembly use case, which is edge computing, right? That's where you can have serverless functions on the edge access some kind of database, and the database is not really mission critical, but it's also a stateful it's a stateful database. So in order to do that, we can have socket connection directly into an instance, but we chose to use host functions, essentially use their C driver and wrap a host function around WasmEdge. But that's the same problem that's I discussed with other people's HTTP wrapper. Is that once you do that, you essentially have a custom built WasmEdge, right? So at this stage, we are experimenting with that. We can, we're happy to do that. But I think once we stabilize which database we want to support, maybe MySQL, MongoDB, Anna, and things like that, we want to make them into proper plugins so that when people install and when people start to play with WasmEdge, they would be able to specify which plugins that they want, and they would then have a Rust SDK and JavaScript SDK that allows them to access those functionalities from within the VM. Right? So those are the things that we are looking at. That's those are in terms of big features, and that's that would solve a lot of our real world use cases of customer our users are already asking for, right? Now, of course, we want to continue to improve our language bindings, and our Rust SDK has done a long way. We started it in the last quarter of last year, and it has seen a lot of improvements, and we really that's and our Python SDK is also Shara here, which within this meeting is working on that, and we have seen a demo that we have seen Python a Python Flask based web application running WasmEdge. So those are all I think great progress that we have made here, right? And well I don't want to hog all the time because this list is long. So so I'll pick some a couple of things that are important. So one of the other things we want to continue to work on is to increase high-level language support. Last year, we spent much of our time trying to improve JavaScript. Like I said, that's so we now export it. If you look at our JavaScript documentation, it's pretty comprehensive. Networking, SSR, streaming SSR modules, and things like that. They all support it, right? And now we are looking to support Python and Ruby, right? That is because Python and Ruby both of them already have versions that are compiled into WebAssembly. So we can just take them and modify them and add our own, for instance, we want to support networking in those languages. We want to support AI inference and, things like that. So add those APIs and reach out to those communities. But one of the holy grail or ultimate goal is to support Java itself. Right? That would require us to run the JVM inside WebAssembly. That is a very large, very big task. But there, you'd be surprised. There's tremendous interest out there to do that. That's to run the JVM inside WebAssembly. It's just nobody has been able to do it yet, right? So that's we have JavaScript, we have Python and Ruby, but no Java yet. So that's one of the things that we want to aspire to. So, and then there's a bunch of proposals, like the module linking proposal and the typed function references, things like that. I think those are looking forward to the future of WebAssembly, where it's truly modular, where you can have a modular repository like the npm, where WebAssembly modules can be published and reference each other, and build an ecosystem like that. We are not there yet, because of those proposals has not been finalized or implemented. But those are very high on our roadmap as well, because we want to be working with people like Wasm Time and Bytecode Alliance, and they spend a lot of time on those, and we want to implement those specs so that we can form a bigger ecosystem, so that all the WebAssembly modules would be able to reference each other, and we'll be able to would be able to link to each other, right? So there are lots of those, and yeah, and in order to support Java, we need Wasm GC proposal, and that's by itself is a very big task, and we also have a lot of edge computing related stuff. So for instance, like I just said, we now have a version of WasmEdge running on Android that can do TensorFlow inference. However, it doesn't have a UI, right? Because Android does not expose its UI to WebAssembly. It's only exposes its UI as a Java library or as a JavaScript library, right? Now, how do we do that? That's so essentially we have to use ADB to log into an Android device and run from command line, which basically means it can use on the Android IoT devices, but it cannot use on Android smartphones, right? Because the user would never be able to use that. So one of the things that we are really looking into is that to have the Android UI library and make it available in WebAssembly as host functions, right? So that in WebAssembly you would be able to say launch a web view or launch a button, something like that, and make it appear on the screen. And the way to do that is to integrate those host functions, native functions as host functions. And one of the very interesting article that I read last week is Amazon published a case study. I think the title is how Amazon updated 7,000 different devices. So essentially, Amazon Prime Video. If you're in the US, you have probably watched it. It's not like Netflix. It's a video service, right? They have their own programming and all that. So the article says they need to support 8,000 devices, different devices types, and in order to have consistent experience and also have ability to update them all at a time, So their applications actually embed a WebAssembly runtime, and which does a lot of the work, and the entire application is written in Rust. So what they did is that they took a Rust UI framework and exposed it in WebAssembly. It's the same approach that we have been talking about, right? To make the host native capability in Rust into a host function that's registered in the WebAssembly runtime, right? That allows the developer to create a UI application for the device, or for the PC for that matter, on the WebAssembly VM. I thought that's a very, very interesting approach, because that sort of validates the thing that we have been discussing with some of the large device manufacturers who want to adopt WasmEdge, right? So that's we did not know that Amazon has already done it, and also done it within the context of their apps, not in the operating system level, right? So that's sort of very interesting revelation for us. But anyway, so that's a little bit background of why we want to do that, right? So there's then their documentation efforts, then open source collaboration. We are collaborating with a lot of open source projects, and we'll have a lot of case studies that come out in the next couple of weeks, maybe in the next 2 months. That's to talk about the things that we do with them, and the things that we do for them. There's a lot of cloud native projects, a lot of edge computing projects, blockchain projects. So yeah, there's a ton of things that we are looking forward to in 2022. So I think I'll stop here. And let you guys ask some questions. So if you want that little tiger on your desk, ask a question.
Thank you. That was excellent. Yes, so much content there. And if anybody, as Michael says, if anybody's got any questions, please feel free to ask away. We're here for you and would love to help.
So if there is nothing else, I would just like to ask, you said a big goal is supporting Java. Do you think running a complete JVM inside WebAssembly is easier than translating, for example, bytecode to Wasm code?
That's a really interesting question. Microsoft claimed that they have made the .NET VM running inside WebAssembly. My understanding is that they took the whole .NET VM, including the garbage collector and everything, and compiled it into WebAssembly. However, I don't think this is necessarily a choice for Java, because at this moment, the open source Java implementation, the Grail VM, right? That's it doesn't seem to be able to do that. It seems to have a lot of barriers to compile it, and I think Oracle may have a proprietary JVM that's written in C, but it's not available to us for us to do that, right? So that is something we are still struggling with. And then there's other projects like I forgot that project's name, but that's one of the Future Way projects, where they can compile Java application into native code. So essentially it's sort of like
like our Java VM.
Right. It's well, Ground VM also does that. It doesn't do the Java bytecode compilation, but comparing to the native code and goes through the LLVM. So so there is a thinking is to say, because LLVM has a WebAssembly backend, is it possible to hack it so that to get because they all have IR, right? So to work at that IR level and generate WebAssembly bytecode, instead of the native code, right? So that is also something that people are thinking about. But I think that's still an open challenge. I think that's probably a larger project than a small team can handle, right? So that's, I don't know Microsoft has how many people Microsoft has working on cross-compiling .NET into WebAssembly, but I'd imagine it's probably more than the number of people on this phone call, right? So
yeah, but still an interesting topic. Thank you.
Yeah, so if you guys have any ideas, let me know. Because that's one of the things that people have repeatedly asked us. Can we do this? Especially the JavaScript people. That's they really seem to want to do that. I told them, you can embed WebAssembly application in your Java application. They said, no, we don't want to do that. We want to run the Java application inside WebAssembly. So okay, well, so.
Yeah, great question. Yeah. Thanks. So anybody else? No question too big or too small?
Just a quick question. When do you expect the 0.9.1 to be released?
I would say in 1 week, in 2 weeks, but hopefully 1 week, because right now is Chinese New Year holiday, and our Taiwan team, like Haidai is not here because he's in Taiwan, right? That's sure. They're all on their biggest holiday of the year, so so I think
they all need some rest, I'm sure. You bet. Okay, so yeah. It would, but before the end of, or on or before the end of February, sounds like it's for reasonable.
Right. I would hope mid-February. Yeah.
Okay. Great. Thanks.
Yeah. Thanks. Yeah.
Cool. Thanks, Brad.
So when there's still time left, I've seen on the agenda for this year that you have debug tools as well as support for draw headers. Have you already gathered some experience on debugging WebAssembly code inside the virtual machine?
Yeah, so this is something we are working on right now, I think. And by the way, all those work is done in open. So if you guys want to be part of it or participate, that you should definitely, join the discussion. I think right now it's just to give more login. There's debug symbols, of course, but that's slated for for a little bit in the future. That's and I think at this moment we want to allow people to turn on verbose, right? To give a lot more information about why it crashes. Because right now, if it crashes, it just to say unreachable statement, something really vague about it, right? But I think there's a lot more information that can be printed to the console. This is a low-hanging fruit that we want to do right now. Is that to give much more sensible, error informations that will allow people to see, why it crashes, right? That's I think a full debugger experience, like allow people to step through functions and things like that would have to come later, unless someone wants to step up and help, right? So.
Thank you.
Hey, Tim, Brad Jones here. We haven't started working with it yet. I spoke with Michael back in May of last year, and we were working in terms of some specific areas. We were kind of looking at a tie-in to PyTorch, which is not quite clear for us yet. But now that with the 0.9.1 release, it looks like we'll be able to start hopefully contributing. I had hoped to contribute far earlier than we have so far, obviously, when I spoke to Michael last year. But you know, this is an exciting project all the way around, and you guys have made great, clearly you've made great progress, and very impressive. So this is going to be the year for sure. That we've got a number of areas we can apply this to. If anything, there's so many, we have to actually, you know, pick the best ones that have the most return for everybody, I suppose. So it's just, you know, obviously it's a big playing ground, that's for sure. Big area to select from. So, and it's getting bigger every month, and certainly this year looks very exciting with all the things on the roadmap as well. And one of the things that we'll try to do is maybe add another integration. We're looking at are you guys familiar with the joint platform with SmartOS and Triton and that sort of thing? Remember the old Solaris?
Yeah, that's but
that's
not Python related, right? Yeah, that's okay.
No, that's not. I'm sorry. This is a little off, but we would certainly like to see if we can get WasmEdge running well on that platform. So then we could have a very scalable cloud native situation that allows us to transcend, you know, the typical world of trying to, you know, in some cases tie into a Fastly or a Cloudflare or whatever. Just basically being able to run our own cloud native capabilities all the way up to the application layer, say on something like Equinix. But that's something I certainly want to talk to Michael and anybody else about as soon as we get to that point. It's just been a resource situation more than anything. And every time we turn around, of course, this bloody virus tends to mutate and do something to us and get Michael stuck in Shanghai or me stuck someplace else, and it just never ends. But we somehow have to live with it. Anyways, we will, I'm sure. But anyways, congratulations to you and all the team, Michael, and it's just an amazing project. I really tip my hat to you guys.
Yeah, thank you. Yeah, that's you know, it's very kind of you to say that. Yeah, that's
my pleasure. And Happy New Year too, by the way. There you go.
Yeah.
Year of the Tiger, year of WasmEdge. There you go.
Yeah.
Good night. You betcha.
Yeah, year of Tiger. Yeah.
Okay.
Thanks a lot.
Thanks, Brad. Yeah, it's a huge roadmap for 2022, and it's very exciting. Can we quickly touch on the PyTorch or any Python issue? As Michael, you mentioned, could we just have a quick mini discussion about that? Any sort of Python implementation? Yeah.
Yeah. Well, yeah, that's so. Well, as you know, the way the Python does, TensorFlow AI inference is through native functions, right? You know, so Python is essentially a wrapper around those native functionalities, and what we are trying to do is to bring, and not necessarily to do it to repeat what Python has done, but to bring this to the Rust community and to the JavaScript community, you know, other Wasm languages, right? You know, that's so that, you know, in the as you can do now, you know, you can write a Rust application, compile to WebAssembly that does AI inference, that without installing Python and all that, right? But Shiraz is working on the Python SDK that allows the Python application to have third-party plugins. So, you know, potentially there would be an alternative than PyTorch would be to have, high-performance WebAssembly-based application that plug into Python. So Python became another front end for a WebAssembly application. And but of course, like I said, you know, we're also working on Rust Python, that the Python application itself can also be compiled into, can run inside WebAssembly and become plugged into, say, another Go application. You know, so that's really opens the door for mixing languages across different applications. But you know, have to say this whole idea is actually, Python really started this whole idea of mixing C plus a higher, to do most of the work in the C, but present a user, developer with a high level language for interface that is Python, right? So I think that's essentially what we do as well. That's so we want to provide, different, because WebAssembly support a lot of different high level languages. We want to have access to, other languages, and Python being one of the important one in the mix, right? So, then to another point, we'd love to see WasmEdge being ported to other platforms. One of the things that we're also working on, we probably should add to the roadmap, is to support it in say, a trusted environment, those Intel SGX, that sort of environment, which is not for Linux, it's just a trusted computing core in the CPU, and the WebAssembly runtime is a much better fit than, say, to have a Docker plus Linux in there. So it's that allows us to have confidential or trusted functions that runs inside a host application. So your host application could have trusted, have a function embedded in it that runs in the trusted mode that runs in WebAssembly, right? So yeah, well, I also see another question in the chat room, and Sherry's asked, for resource constrained system like the ESP32, which is it's like MCU this big, that's how do we do it? Originally, WasmEdge is not designed for this type of very small devices, because it has a fairly modern infrastructure, so it mostly deal with 64-bit infrastructure, so LVM and all that. However, we also see a lot of demand for that, and we figured out a way to do that, is to cross-compile it. That's the other idea we talked about, is to, I don't generate a WebAssembly bytecode anymore. I generate a native application that has WebAssembly in it. That allows us to manage the whole memory space on those devices much more efficient. So that's probably the direction that we're trying to go, perhaps later this year, because we don't have a very pressing need for that. No one is asking us to say, can you do this right now, right? Because I think people who really want those very small devices are still either evaluating a Wasm runtime, or they are, some of them choose WMR, and but so far, I would say a cloud native runtime like WasmEdge does not have a really coherent story on those devices yet, because we are, we can run on those devices, but we are very big, and compared with 500K memory that they have, we are very big. So so the approach that we have validated and we just need time to work on is to do the I would say native compiling, just to have to build the WebAssembly runtime into a native binary and then run the native binary. It's the same idea that the Grow VM does for the Java bytecode, right? That's so all those ideas, and none of them are exclusive to each other. That's so we we can, they learn from us, we learn from them, right? So
yeah, awesome. Yeah, very interesting. Very, very interesting. So yeah, just a bit over an hour, which is great. Really great discussion. Any other questions at all? Anybody wanting to share anything they're working on? Yeah, Calvin?
What do you think's holding back the next level of adoption, either of Wasm in general or WasmEdge?
Well, that is a good question.
yeah. So perhaps I can give some light on that. That's I think awareness is a huge thing, because when people hear about WebAssembly, it's very confusing to them, what it is. Because the way we talk about WebAssembly is neither web nor assembly, right? That's then we say WebAssembly is a new container format. Why? What are you talking about, right? That's so that's I think this outreach and education program is very important. And like Brad said, one of the huge issues in the past 2 years or so is, because we can't run face-to-face conferences, that we can't meet face-to-face. So it becomes it's very difficult to explain people what it is and why do you need to learn it, right? So people's, it's something that requires a significant amount of explaining. And I think the interest in WebAssembly has really taken off in the past 6 months, which coincides with people who was finally able to meet again. That's so when I go to places like KubeCon and people say, oh, okay, that's how you use WebAssembly. That's because in their mind, this is a browser technology. They have never thought, why would you want to use it in Kubernetes, right, for instance? That's so I think, the barrier is being broken down, so I have, really high hope. That's in 6 months or 9 months, by the time we have most of the items implemented on our roadmap, it would become, really popular now. That's because it solves a lot of people's problem, because, if you ask people what's their problem with the Kubernetes cluster, they're going to tell 2 things. Every single one of them is going to tell, one, it's overly complex, it's too complex. And the second is, it's overkill to start a Docker instance for every little task, right? That's I was just talking with one of the largest SaaS providers in North America, and we were talking about their notification system, and they said their notification system is not done well because it's because the architecture limits. That's whenever they send an email, they send a notification, they have to start a job. And because their granularity is that the job, the runner, is a Docker instance. So essentially, every time they send an email, they start a Docker. And that's really, from them, it's very resource consuming, and that's really hinders their ability to innovate on this space. So I basically told them, that's why don't you have lightweight runners like WebAssembly, right? That's I think those people, a lot of those potential customers have not really heard about WebAssembly or have their mind here, because when they look at problems like this, they're thinking about a lighter Docker. If you look at Google, they have distroless, right? Those are very lightweight Linux images on Docker-like containers, like that images that are smaller than Alpine, right? So they were pushing for that direction. That's which is fine. That's because it's integrated into their existing infrastructure. But the way that we did it with WasmEdge, we also integrate into their infrastructure, because we have all those Kubernetes integration already, right? So so I'm really hopeful. That's more people are hearing about that. More people are now understand what this does and how they solve their problem. So that's yeah. So Kim, you have anything?
Yeah, that's a good point. I think one of the things that I'd like to see happen with WebAssembly, because it definitely lends itself to this, but sometimes in the real world things don't pan out like you expect, and there's normally a good reason, but we kind of need to discover the reason. So the idea or the concept is that because WebAssembly is obviously be able to run on multiple platforms and things like that, is code reuse. So you write something as small as possible, preferably, and you publish that officially as a solution to problem X. And then you, like you're talking about before, you have like a signature. So what we were doing on the HTTP request was we just had a hash of the source code, and then the application was able to, before it ran the code, it would obtain the hash and it's a match, run the code. And obviously if that was different, then it would not run the code. So the idea of code reuse is that you would publish this globally, and then if somebody had a better idea about how to do something, they could go and like fork that code, enhance it, run some benchmark testings, prove their efficiency or whatever goal they have in mind, or speed, and then they would publish that, and then other users would be able to just utilize that small piece of code, so that logic. And then you piece all these pieces together, and especially with all these containerized frameworks and things like that, you start to have a really amazing scalable solution. But my only sort of parallel with this for a while ago was looking at learning and teaching space and open educational resources, and the fact that a teacher could just go ahead and get something like a lesson or some content or resources that were already created. And for some reason, after years of people trying it, it never really took off as one would expect. It was sort of illogical that it didn't just become the norm. And after lots of research and digging down, it actually turns out that there's like a whole nother side to it, which is that teachers are busy and time poor, and they have a lot of additional things which are supplied by, say, a publisher, which is exams and questions and answers and all pre-written things in the back of the book, in the teacher's edition. So there was like this underlying reason why they would actually just default to, we'll just buy that, and that provides this immense value, which is over and above just this core idea of reusing resources. So it made the reuse thing seem fairly shallow when you look at the other side, which is this enriched experience that a teacher has by just paying for a particular publisher's solution. So I was talking to Raw Code when we did that session there, and we were talking about, I think he said it was called Google Intents or Google Intentions or something. It was that there was an idea in the past where it was exactly this. You have something and you write up what it intends to do and how it works, and then a caller can call that and say, look, I want to achieve this, and it browses through like a library of solutions, and then it will pick one, and then it basically actions against that, and then the product will give back what the person intended to do. And I thought that makes a lot of sense, and that's a really cool solution. But maybe that needs a whole ecosystem built around it, a community awareness, a system where you can go and search. I think we talked about ages ago, like about a couple of years ago, like Yelp for functions. You go and search for functionality, and things are rated and they're tested, and you can compare and contrast, and then you pick one and you use that. Maybe some centralized sort of hosting might be sort of like an NPM type place where you go and do a search, grab a tool, implement it. Obviously, it would be better, safer, all the features of WebAssembly. But yeah, so it's maybe it's early to answer the question, because it is very early. It has been. So I just looked. It's February, so it was 2 years ago when Michael and I were together and looking at the first WebAssembly summit that was held. And then at that meeting they were like, "Do you want to hold this again next year?" And we were like, "Yeah, we vote yes." And now I'm realizing it's actually 2 years since that day. I think it was like the 8th or the 10th of February or something. And it was like, yeah, WebAssembly. And then now it's 2 years later, and I haven't left the house. So but yeah, so I think it's early days, and maybe B, we need to maybe some involvement with some companies. I think people starting to use it is healthy, and then the employees start to go looking for solutions. I remember meeting, which is a great example, the people from Shopify. They're just having lunch, and just having a chat. Oh, what do you do? And then this whole conversation opened up about how Shopify is able to have customers build modules that are separate to the actual core product that they're shipping, and they can use WebAssembly as a safe sandbox thing to people to customize checkouts for individual stores and things like that without actually modifying the Ruby code that ships as the standard. So yeah, there's a lot of interesting use cases, and so one, it's early. B, we probably need to meet more and chat and have casual conversations. But yeah, so
Great. Yeah. So I like the idea of Yelp for serverless functions, right? Yeah, that's you know, the meeting Tim talked about was at Google Campus. You know, that's you know, I think we should do something like that, maybe second half this year. You know, that's you know, it's we can get the community together and try to do that again. I think there's you know, plenty of interest. You know, there's KubeCon in Europe in May. I think after that we should do something like that in the US. I think. So
yeah. One thing that surprised me when I was talking to the people there on campus, I sort of my go-to thing was, you know, I've only got a couple of minutes. We're on a small break. I'll just grab your social media handle or something and we'll connect. And I noticed that a lot of the people that were really hardcore developers in this space, they weren't actually on social media, which was interesting. And so it was like, oh, well, can I grab your email address and send you like a one-to-one personal message and go that way instead? But so it was interesting that maybe discovering each other online is a bit more difficult because we're very busy, you know, say in a job or on a project, and you sort of nose to the grindstone and working on that, and not so much sort of dabbling on sharing and things like that. You sort of got a very specific niche outcome. And so I hope people can find us, you know, on GitHub. I think that's good. And if anybody in the meeting or anybody watching this video wants to share this, that would be brilliant. Just, you know, on any social media platforms that you're on, or any sort of email lists or groups or meetings at work, just put it out there. Share the GitHub, share the book. The book's excellent. You can go through that. Just help spread the word, spread awareness. That would be a great start. And thanks everyone for joining. It's great.
all right. Yeah. So everyone who has questions, I think Tim, Seven, Brad, Shiraz, and Colin, right? You know, send me an email. What's your address? We'll send you a little gift. You know, Michael@secondstate.io. I think you guys all know that, right? Let me put that in the meeting notes. Send me an email, and you know, and happy Chinese New Year.
Yeah. Happy New Year. Thank you everyone for joining us, and we'll see you again next month.
Yeah. All right, guys. Thanks.
Thanks, guys. Bye.